Hello everyone. Today I'll show the solutions to the Prairie Math League High School Round 135 problems 5 and 6. For problem number 5, if 4 sine A plus 3 cosine A is equal to 5, where A is an acute angle, find sine A plus 2 cosine A plus 4 cotangent A. Well, first of all, we have the Pythagorean triple 4, 3, and 5. We also see sine and cosine. So this can remind us of the Pythagorean identity, which states that sine squared A plus cosine squared A is equal to 1. To take advantage of this, we move 4 sine A to the other side, here, and squares both sides. And now we can use this Pythagorean identity to eliminate the cosine variable entirely. So we only have sine A variables. We can just solve for sine A by rearranging everything to putting everything to one side, factoring f to get 5 sine A minus 4 squared, and then we see that sine A is equal to 4 over 5. Now we can use the same identity to solve, given sine A, we can solve for cosine A, and we see that cosine A is equal to 3 over 5. From here, cotangent A is equal to cosine A over sine A, which is 3 over 4. Hence, the desired expression is equal to 4 over 5 plus 6 over 5 plus 3, which is equal to 5. And the answer is E. For problem 6, 3 real numbers A, B, and C are all in the interval from 0 to pi over 2 exclusive. If cosine A is equal to A, sine of cosine of B is equal to B, and cosine sine of C is equal to C, which is the increasing order of the 3 numbers. So first, we note that x is greater than sine of x, for x is greater than 0. Now, why is this? To see this, we examine the unit circle. For any angle A we select, we see that the arc length is also of length A, by definition. Furthermore, sine is this length here, sine A. This is because sine A is just the height from the point on the unit circle to the x-axis. Now we can see that this here, the arc length, is always greater than the height, because the height is the shortest distance from the point to the x-axis, and the arc length is not the shortest distance to the x-axis. Hence, x is greater than sine of x. Now we can use this. From this equation, we have b is equal to sine of cosine of b. Now, as we just saw, this means that sine of cosine of b is less than just cosine of b. Hence, cosine b is greater than b. Now we examine the second diagram here. Notice that this is just the graphs of y is equal to cos A and y is equal to x. Sorry, y equals cos x and y equals x. Now, note that the solution is, of course, A, since cosine of A is equal to A, has this solution here. Now we can see that since B is less than A, B must be somewhere in this region on the x-axis. Oh no, this is, okay, messed that up. Sorry, ignore that. Note that since cos B is equal to, greater than B, we have that this part is greater than this part, which can only happen in this region here, because in this region, this part is greater than this part, and hence B is in this region, so B is less than A. Now, furthermore, we can see that B must be here, right? So we see this is B. Now, from the equations, note that cosine of sine of C is equal to C, and sine of cosine of B is equal to B, from which we can naturally deduce that C is just equal to cosine of B. Now, this is true, since B is equal to sine of cosine of B, but then you can just repeat this forever. like, and C is equal to cosine of sine of sine, and you can again repeat this forever. Now note that just C is just the cosine of this expression here, and this expression here is B. So C is equal to cosine of B. Now this is a risky argument to actually use, and it's going to be harder to prove, but it's kind of like a lifesaver when you're trying to solve the contest itself. So we see that C is equal to cosine of B. So we have this point here at C, because this thing here is cosine of X, or cosine of B at this point here. Now what do we notice about C? Well, C is greater than A. So let B is less than A is less than C, which is option choice B. Now honestly, there's a bit of a cheat to solving this problem, and it's to just take a calculator. To find A, you go into radian mode and smash the cosine button as many times as you want until cosine of A stabilizes, and you get an approximation for A. Now for the other two, B and C, you just alternate pressing the buttons sine and cosine. So again, you're in radian mode. And yeah, this is kind of a dirty trick, but it's a way to solve this problem like really quickly. And you again see that B is less than A less than C. Thank you for watching.